little bit. That's better. All right, so describe cloud concepts. Cloud concepts. Let's see here. Identify the benefits and considerations of using cloud services. Maybe do some headline stuff. What do we got here? Heading. Yeah, that's better. So identify the benefits of cloud computing. So yeah, this is really just saying, why would someone use the cloud? If you've got, so high availability would mean that it's up a lot. And theoretically, like let's say I was trying to set up some server, I bet it would go down a lot because I don't know what I'm doing. I don't know how to set up a server. So I'm sure Azure has higher availability than I could provide. Scalability would be scaling up, I believe. So if you have one VM, let's say, then you can scale it up in the sense that it can have more processing power, more cores, more RAM, stuff like that. Whereas elasticity, I believe, is scaling out so that you can have more VMs and they're all working on the same problem, let's say, or you've got like web traffic coming in. You can have these different web servers that are handling that traffic, and you're load balancing that traffic, and that I think would be elasticity, is scaling out. So let's check that. Elasticity. I'm just Googling some stuff on the side here. Versus scalability. Adding resources. Let's see if we can put in Azure. I'm trying to get there. So throw this into here. I just realized that I'm blocking probably some of this stuff, eh? Yeah, a little bit. All right. Let's move me over here. Scale environments only care about increasing capacity, accommodating increasing workload. Elastic environments care about being able to meet current demands without under-conditioning in an automatic fashion. Scalable systems don't necessarily mean they will scale up, down. It's only about being able to reach peak loads. Elastic workloads, however, will recognize dynamic demands and adapt to them. Okay, so I think I was wrong a little bit. So, scales don't necessarily mean that they will scale. It's only about being able to reach peak loads. You have a web app that needs to support 1,000 active users for one day. So you can provisioning 10 servers until after that one day. You only have 10 active users, thus you only need one server. Scalable system will be able to scale to meet the 1,000. So that's cool, our system scaled. But now we're left with an abundance of over-provisioning capacity, and we have to deal with that. If the system was elastic, the process would have been automatic. Okay. So it sounds like elasticity. Oh, and this goes with it here. Okay. I don't know why that's tabbing quite right. That's so weird. Anyways, elasticity is okay. Elasticity is where there's automatic scaling, I think. So they're not necessarily two different things. It's just that there's scalability where you can scale up or scale out, and then elasticity where it automatically scales. And so, that's something I've seen at places that I've worked where it's automatically scaling throughout the day to meet a certain amount of workloads, but then, there's other parts of the day where it doesn't need to be scaled up and it automatically scales down. A perfect example of where that's really nice to have the cloud is, if you had some sort of company that was running like a Super Bowl ad, and they had a website or some sort of app, when that, before the Super Bowl, it's probably getting like hardly any traffic at all. But then their ad runs, and then it's just through the roof, and then starts to decline slowly after. So you'd really want that to be scalable, and you might automatically provision that, or you might manually provision it. I don't really know what goes into those decisions, but yeah. Now agility, I would say agility would be, it's like a developer with certain permissions in Azure. I can go in and just boom, set up a web app, and I can set up a VM, different stuff I could provision for myself very quickly, in comparison to some of the stuff on-prem, especially under certain companies. You've got to put in like a ticket, and then they, potentially have to find the hardware, and then, if you've got a small business, let's say, you might not have a server at all yet, and so then they've got to find that hardware, and figure out how much it's going to cost to get quotes and all this different stuff, and then it gets shipped, and then they set it up and all that stuff. That would be like worst case. Compared to Azure, I just click some buttons and bam, I'm going. And then disaster recovery, there's built-in stuff in Azure to recover from any sort of disasters, and that's kind of multiple ways. There's backups. You can automatically take backups, but then there's also, I guess this gets into high availability a bit, but there's different availability zones where if one data center goes down, then things can kind of switch over, or some servers in a data center go down, it can switch over, and so you can kind of recover from some of those different types of disasters. So let's see here. I don't know why this tagging is so weird. We got like a ruler. What happened to the ruler? So I think I want to do that. just want to do that. Whoa, crazy. Let's not go overboard here. Identify the differences between capital expenditure and operational expenditure. This one's pretty easy, and I think a lot of people could just kind of guess what's going on here. Capital expenditure would be expenses on actual things that, like the classic example is, buying hardware for setting up your servers. That's a capital expenditure. Whereas an operational expenditure is more kind of routine costs to operate something. And so you could have operational expenditure on premises servers, and that would be like the electricity and the people to keep everything running. But then Azure kind of only has operational expenditure, the cloud. You're not buying, any sort of hardware from Azure. Azure owns that. Microsoft owns it. But you definitely are paying, monthly costs. So pretty straightforward one. Describe the consumption-based model. Yeah, I mean, that's kind of what I just talked about, where with cloud, okay, so no, it's a little different. So like Azure Functions can work this way, where you pay per trigger of the Azure function, or CPU cycle. I can't remember exactly. It would be CPU cycle. Yeah, for sure. That's what it is. So it's just pay as you use it, right? Pay as you go, that kind of a thing. Pay as you use it, actually, specifically. Whereas the alternative is just kind of routine costs. And so you can have Azure functions that are provisioned as an app service, I think is what it would be called. And it's pretty similar to if you have like a web app on Azure, where you just kind of have like at least part of a VM that is just running kind of like all the time. And it just costs X amount of dollars per month. And that can go up if you want things to scale and stuff. But yeah, that's basically the difference there. Describe the difference between categories of cloud services. Yeah, okay. So here we're getting into multiple cursors. So the IaaS versus PaaS versus SaaS and functions as a service and different stuff like that. It's all blank as a service, right? So infrastructure as a service would be your virtual machines. So you don't have to set up the hardware, right? But here's the VM. You've got to configure everything else. And so you're in charge of updating the operating system. I mean, I guess theoretically you could install your own operating system. Usually they have one already set up. But yeah, updating it's kind of the big one. But then also in charge of like setting up different features and software, services that run on that. to just do what you want to do. So it's more control that you have over it, but more responsibility on your part to get things right, and generally more costly per whatever you're doing, per hit or something like that if you have some sort of web app. But can be the easiest because if you're switching from on-prem to the cloud, you just get a VM and you just hop over your VM, and it's not necessarily just that easy, but it can be a lot easier than trying to switch it to some sort of platform as a service offering. Now, platform as a service would be like the web app as a service, or SQL as a service, where you don't have to update it. You're not really necessarily worried about the operating system. You can choose usually between like Windows and Linux, because it does come with some feature benefits or drawbacks, and then cost differences. But other than that, you're not really worried about the operating system. You're not updating anything. And there's a lot less that you have to configure. Now you still have some configurability, and it's your code that's running on it. So that's kind of the big thing, or it's your data that's in it, for SQL as a service. But yeah. Whereas software as a service would be, like let's say I could make my own CRM, and it would be my code running on a web app for the PaaS solution. But the software as a service would be like using Dynamics CRM, which is Microsoft's CRM, customer relationship management. So you have a lot less that you're configuring, a lot less that you're responsible for. They're updating everything. There's no code that you're writing necessarily. You might be able to do some plugins and stuff like that, but you have less customization that you can do, but it can be good, and it might be cheaper. Kind of depends. When you're comparing it to like hiring a bunch of developers, it could be a lot cheaper. So serverless computing would be where you have code generally. You're putting it into like an Azure function, and then it's running that code, but you don't really care what it's running on. So it's kind of similar to that web app, but it's just code. It's just kind of functions as a service. So it's not necessarily a web app. It could be code that spits stuff out to a database. It has no GUI part at all necessarily. Identify a service type based on a use case. So yeah, that'll, maybe, I don't know, at some point I'll hop back on and we'll do like a practice test together. Maybe. And that, like in some of those practice tests, they say like, Jimmy's got some data and he needs to store it someplace, doesn't know how to use VMs, he knows how to write SQL. What should he do? Like, okay, SQL as a service would probably make sense there. And they kind of get into these different scenarios, and you have to talk about explain which service they should use. Shared responsibility. So that's kind of what I've been talking about. And actually, there's a little diagram that I could throw up here. Shared responsibility model Azure. Is a small image. It is also a small image. What the heck? It's a little bit bigger. There we go. So this kind of just cloud in general, not Azure, but it's basically, you know, kind of all the same. On-premise, yeah, you manage everything, right? No one's managing anything else. Azure's not managing anything on-premise. Now you can do some hybrid stuff where that could change, but that's different. Infrastructure as a service, you're managing applications, data, runtime, the middleware, the operating system, you know, it's a big one. But then Microsoft is managing, yeah, network, storage, servers, virtualization. So kind of more of the bare bones part of it. Platform as a service, you're throwing your data on there or your applications in terms of code, maybe some other type of application, I guess you could run without, you know, it would be really cool, but you might not necessarily have to know how to code to throw it on there. And then software as a service, where everything's managed for you. And, you know, I guess it's still kind of like your data, but you're not managing your data necessarily. Like, you own it, you own your data, probably, but you're not managing it. So that's the difference there. Wow, I'm smart. Describe the difference between types of cloud computing. I'm just going to see. I think we're doing good. Describe the differences between types of cloud computing. Okay, so we're getting into hybrid stuff a little bit. So, yeah, cloud computing would just be you're kind of just running something on someone else's computers. You're computing on someone else's computers that you don't own. They're not on your premise. You don't own them. You know, typically it's some sort of business, and you're streaming data or doing something kind of over the internet generally. Not necessarily, but yeah. So, and you know, public cloud can be something like a Dropbox or Google Drive or something like that. That would be maybe most people's exposure to the cloud. But, you know, in kind of more of a professional sense, it would be something like Azure, Amazon AWS, Google Cloud. And you're, you know, paying them for compute or storage of files or data, different stuff like that. Private cloud would be if you have your own company, you know, like an on-premise servers, and it's something that you can access with like a VPN, but it's private to your company. Hybrid cloud would be where you've got Azure, possibly like they've got servers at your company. They're maybe managing those servers, but they're on premise, they're in your network. And you can, theoretically, like there's some tools, I haven't played around with it, but some tools where you can kind of use like the Azure portal and provision stuff in a kind of familiar way if you're used to Azure and the Azure portal, but you're provisioning it on your own servers that are like on premise. So that's kind of cool. Definitely a lot lower latency. But can be costly. It depends. Compare and contrast the three types of cloud computing. Yeah, I mean, we basically kind of just did that, but so I guess I'll say this in terms of like costs. Like, if you have a consistent workload, so like most people, most companies probably have like a consistent workload, at least during the day, where they've got like 100 people using it. There's maybe this much data traffic going through and stuff, but it's very like kind of flatline. Then you would want to, in general, you want to have your own servers, do stuff on premise, because you can very easily predict how many servers you need, how much cores you need, RAM, all that stuff, and just provision it. Provision a bit extra, but provision it for what you need, and then boom, just you're done. And all really you're paying is the people to manage that, and the electricity costs. And in comparison to the public cloud, there's a good chance it'll be way cheaper. But if you have big spikes, we're talking about like that Super Bowl example, where there's this huge spike, you don't want to buy like 100 servers to handle that one spike and then they never get used again. Like, that would be crazy. So that's where you want to do something like public cloud. So the more consistent your workload is, the more you want to buy your own stuff. But it can depend on a lot of factors too. You might not be able to find anyone to manage servers, or you might not be able to find the hardware at times. That's probably happened in this last couple of years during the pandemic. I haven't tried to buy server hardware, but I bet there were some issues there. Might still be issues in finding it. There's a lot that goes into it. So, but that's some of it. So now we got another chunk here, and this is 15 to 20% of the exam. Describe core Azure services. So I would say I feel like I know this stuff pretty well. I had a little bit of issues with the elasticity scalability thing, but I think I've got that down pretty good. Maybe I'll mark it with like a green. You can barely see. Oh, that's right. I wasn't going to do bold. I was going to do heading 1. Did I just change? No. Okay. It's just great. Describe the core Azure architectural components. Benefits, okay, usage of regions and region pairs. So regions, I believe, would be like where it talks about like central US, eastern US, different regions throughout different countries. And from my understanding, there's usually like one data center in those regions. But then a region pair would be where they kind of pair up two regions that are connected with, really high throughput cables that are, close to each other. But if one goes down, they can kind of switch to the other one relatively easily. I think I should probably look this up. I don't necessarily know if that's true. Azure regions. Let's just do region pairs. So large-scale phenomena is where I think you get into the region pairs. Azure regions are designed to offer protection against local disasters with availability zones. Yeah, because availability zones, I think it's kind of the same thing that I was thinking of. So what's the difference? Support availability. Abilities zone versus region. To achieve resiliency. Each Azure region features data centers deployed with low latency defined, connected through a dedicated regional low latency network. So, okay, so I think a region is multiple data centers grouped into a region. And they are connected with the low latency network. Ensures that Azure services within any region offers the best. Azure availability zones are physically separated locations within each Azure region that are tolerant to local failures, hardware failures, earthquakes, floods, separate availability zones are present in all available Azure zoned enabled regions. That's a cool little graphic there. So these are in an Azure region. There's multiple availability zones, these different data centers that connect to each other. So I think I got that. Cross-region replication. Cross-region replication. Asynchronously replicates the same applications and data across other Azure regions for disaster recovery protection. So that would be where you've got these region pairs, I believe, that it could then use that backup to kind of restore in another region if like a whole region goes down or something crazy. So in Asia Pacific, you've got East Asia, Hong Kong, paired up with Southeast Asia, Singapore. So if you've got, some tsunami or something crazy comes through, wipes out that whole region, go back, you're paired up with this other region, you still have your data and everything. So that's interesting. So we talked about availability zones then. Resource groups is pretty simple. It's when you're creating some sort of Azure resource, a web app. You might pair up a web app with a SQL database if it's for that web app. You might pair those up as a resource group, and there might be some data storage that's also connected with possibly both of those. So you group those into this resource group. Let's say it's something where it's for that Super Bowl commercial. It airs and it's done. You're never going to use it again. Obviously, you still have the code and maybe some sort of database backup or something like that. But you don't need it running anymore. You can just shut it down. So you could control that whole resource and shut down that whole resource with a few clicks versus having to do it on each one. So yeah. Subscriptions are another way of controlling multiple things, services, and I think a subscription can have multiple resource groups. I think oftentimes you'll use it for security reasons, and you can kind of limit which resource groups a subscription has access to. It's a pretty good graphic from what I remember. Management groups, subscriptions. Yeah, here we go. That's a lot better. Open. So we've got the management groups as well, and I think management groups are just multiple subscriptions. And I guess they can include multiple management groups within those as well. So you might have a subscription for different departments, subscriptions for different environments. subscriptions for different projects. And within those have different resources that they manage. But I think in terms of security, that's really where subscriptions come into play. And you might have some sort of IT admin who controls all this stuff. But then possibly within that, maybe the app devs, or maybe like a specific group of app devs, they have control over a management group of other subscriptions there, but they don't have control over everything in the whole company. They just have a chunk, their branch. So you can get real granular, basically, with those. Azure Resource Manager, is that the ARM templates? So it's a management layer that enables you to create, update, and delete resources in your Azure account. Use management like access control. 5 people watching. Well, actually 4 people. Provides a management layer that enables you to create, update, and delete all resources in your Azure account. You use access control box tags to secure resource attribute. Okay, so ARM templates, yeah. Okay. So, yeah, my understanding of this. Okay, so it's the thing that groups all this stuff together. Gotcha. So, yeah, you've got different ways to interact with Azure and manage your resources, right? The portal is the graphical interface, the web one. Then there's different SDKs, APIs that you can use to interact with to do it without a graphical interface, with code, or with an API calls. So PowerShell, the CLI, so that's commands, but it's not PowerShell. A REST client calling it through an API. You probably do that through code. And then you can also use ARM templates, ARM meaning the Azure Resource Manager templates that are a declarative way of setting up resources. Explain Azure Resources. Yeah, I did before. Describe core resources available in Azure. Okay, this should be fun. There's a whole lot of them. There. All right. So I think maybe I'll get through here and then I'll maybe call it for the day because I got some stuff to do out in sunshine, and we've only got another hour and a half of sunshine. So yeah, maybe another 15 minutes here. So describe the benefits and usage of virtual machines Azure App Services, container instances, Kubernetes, virtual desktop. So virtual machines is pretty obvious. It's just virtual machines. And you can RDP into those virtual machines or SSH or whatever you want to do. Azure App Services, just where you can host apps, web apps. You can do functions in those, like I was talking about before. But yeah, you're not it's not a virtual machine. You're not managing the operating system. A container instance is where you can have like Docker containers that are running, and there is like some patching and stuff. You are kind of in control of operating system a little bit, but at the same time, depending on how you treat your containers, usually the saying is you treat them like cattle, not like pets. So you would just blow them away and set up new ones, and so you don't really have to like update them. You just delete them and recreate them. But yeah, that's where you would put like containers. Kubernetes is similar. You have containers, but it's where you need so many containers, need them interacting with each other in certain ways that you have to have a container orchestrator. Kubernetes is a container orchestration system, a very complex but very useful one. Azure Virtual Desktop is basically just like a computer, like a kind of like a laptop in a way, or like your own computer, but it's running as kind of like a VM, but you can virtually connect to it. I think it's maybe a little bit cheaper than a VM would be. And yeah, there might be some specific benefits to that, but it's basically just a desktop that's kind of in the cloud for your personal usage. Describe benefits and usage of virtual networks, VPN gateways, virtual network peering, and express route. So a networking part of it's real hard for me. So we might just highlight this red and circle back to it. And speaking of which, let's maybe highlight this is red. Let's just do that. So we had a little bit of trouble there. Virtual networks, so I'll try. I believe that virtual networks would be like within a resource group, you can set up this virtual network. So kind of just like at home, you have like your personal network, and if you could have that and not connect it to the outside world, but those devices can still talk to each other, right? They're in their own little network. So you can do that within Azure, and even though theoretically everything's connected to everything else in Azure, it's virtually connected so that you can kind of change that so that through software and stuff, it can't connect to other things if you set it up that way. I think there's some good graphics that help with this. Why are all the images like just insanely tiny? Need them big images. Bigger ones, yeah, there you go. I was hoping to get kind of multiple virtual networks and how they can interact. This one's pretty fun. So yeah, you get your on-premise network, those different computers there, and you could have kind of a private cloud set up there too. But then you have a gateway set up that's controlling traffic to Azure. Azure's got its VPN gateway, so you can VPN in to then and into that Azure virtual network to then talk to this group of VPNs. I don't know what exactly that symbol's representing. If it's just that. I know when you get into, I think I said VPNs. I meant VMs. I know you can. There's a term for having like multiple VMs kind of grouped together and can manage them together, but I'm not sure if that's what it's getting after. No clue what an Azure Bastion subnet is. I don't think that's going to be on the test. Then you can connect it up with the network. Azure VPN. Yeah, this part I don't really quite understand. That's kind of what we're getting at here, was what I was talking about. Yeah, firewall. See, I get into the subnet stuff. I really don't quite understand. I think it's just different ways of splitting up your IP schemes. VPN gateway, virtual network peering. Let's come back to this. I think that's going to take a fair amount of time. I don't think we necessarily have that right now. Container blob storage. Blobs are what? Binary large object. Something with a B. But yeah, basically it's just big files for the most part, and there's not a whole lot to the storage. There is some more advanced stuff when you're talking about like different types of files and kind of like how they're split up and the data that's in them, that you can do things in certain ways, and then how you're going to like serve that data. But for the most part, it's just, you can kind of just think about it as just like files. Disk storage, I don't know exactly what they mean by that, other than just, I mean, maybe they're talking about like hard drives versus SSDs. I know you can choose that in Azure. Storage tiers, yeah. You can get into your usage. Azure storage tiers. Yeah, hot, cool, archive. Apparently there's a premium tier too. But hot meaning that you're using it frequently and you want low latency. You're willing to pay more for it. Cool meaning that it gets used a little bit, but it's not super often. doesn't matter as much if it's a lower latency and you get a lower storage cost from that. And then an archive tier would be where you really don't use it often, rarely accessed, and it can take a fair amount of time to get it, but it's much, much cheaper. So you can control this yourself on your files, but you can also kind of have Azure control it a bit where you put a file up there, you know, it originally thinks that it's hot, but then people aren't really using it, moves to cold, people still aren't using it, and then it eventually moves to archive, but maybe somebody starts using it and then it kind of moves to up a little bit if it just depends on the usage. So I think that's what they're getting at there. And there's, yeah, like different, yeah, I don't think they're going to get too much more into that. Okay. So the benefit usage of Cosmos DB, Azure SQL database, Azure database from SQL, Postgres, so Cosmos is in a way just kind of like Blob Storage. It's basically no SQL. You just have these, you know, your data is just kind of like these objects thrown up there. Not really objects. It's just like chunks of data. And really the way of telling them apart is usually by some sort of like ID. And that's kind of like, it can be seen as like the file name. And then there's like partition keys as well when it gets into like grouping them. There's some different APIs in order to access it, so you can use SQL to query your data and to throw data in there, but that doesn't mean that it's the same thing as like a SQL server and I'm trying to think of the word. But, you know, where you have, you know, objects, you have columns and primary keys and foreign keys and that type of stuff. There's a word for it, I can't think of it. But it's not like that, and it's much cheaper. Whereas Azure SQL database is basically like SQL Server as a service. You can throw your data in there and you can query it with SQL, and you can do all the same stuff that just any SQL server. Well, Microsoft SQL Server you can do. Well, no, okay, so it's not everything that you can do with SQL Server. There are definitely some things that you can't do, but it's pretty similar compared to Cosmos DB. So then Azure database for MySQL is trying to basically be like a MySQL as a service. Yeah, there's not much into it. You know, Postgres is Postgres as a service, basically. SQL managed instances, that one. Don't know. Think about it. Don't think too hard. SQL managed instances. Okay. So it's Yeah, 100% compatibility with latest SQL Server Enterprise Edition. So that would definitely be different than the Azure SQL Azure SQL database. SQL manage instance allow existing SQL servers, customers to lift and shift. Has capabilities, automatic patching, version updates, okay, so probably more expensive. Here we go. So they're both PaaS. So yeah, really looking at that versus Azure SQL database. Share a common code base. So always on, high availability. Can't attach a database. Auditing, yes. So who's on the right? It's the managed instance. Active Directory. So no, only system initiated automatic backups. Or you can have user initiated copy only backups. Built-in functions, most and all. So I really want to know, why would you use Azure SQL database? So it definitely seems like, you know, you've got some missing features. Cross database 3-part. So yeah, you can't query cross databases. Definitely. We don't need to go through all of them here, right? Can I just get why you would use it? Oh, wow. Get a summary. Differences. Here we go to, come on, I'm gonna load here. Azure SQL Manage provides native VNet integration, while Azure SQL Database enables restricted virtual network access using VNet endpoints. Manage instance, okay. Big differences. So here we go. Choose, you don't need native VNet integration, but need all the benefits of the fully managed platform as service. Use SQL database when application services components running in Azure Service. application services components. Don't really know what that means. It just seems like there's got to be a big price difference, because otherwise, why would you use Azure SQL Database? Well, that's what I'm going to go with. Describe the benefits and uses of Azure Marketplace. So that, oh. All right. This is okay. So Azure Marketplace is just the place to on the Azure portal to set up your services, and you can kind of find out what different types of services are out there. You can get a sense of pricing and what it takes to set them up. Yeah, so we're at 4 o'clock. It's about when I wanted to stop. So we'll get into core solutions management tools. So I mean, kind of just more of talking about different services. And security is a big chunk, one that I probably don't understand very well. Identity, governance, privacy. So that's obviously a big one that I don't understand very well either, probably. Azure cost management, yeah, SLAs, that's another one that I don't understand quite so well. Oh man, there's so much. Oh, what do we got here? Some like example guide below shows the changes that were implemented. Okay. So we don't need any of this because this is just showing us changes. The top part is with the changes already in. So, you know, there's a good chunk left to study here. Halfway, third, maybe a third way through. So we'll see. I kind of think this is a fun way of doing it. Basically the same thing that I would have done before, just streaming it. And apparently 5 other people are also watching. Probably most of those are bots. But at least it's recorded. Maybe I can turn these into some videos or something. And I think it's kind of fun. So I'm going to sign off. Have a good day, everybody, and talk to you later.